In this video, I'm going to show you how you can verify your smart contracts on etherscan or BSCscan, any other block explorer using Hardhat. Because I did a video on this channel a few days ago where I showed you how to verify a smart contract manually using the etherscan website, where you copy and paste your contracts into the little box and you press verify, and that works. But if your project is large, you have lots of files, lots of dependencies to external sources and so on, it can be very cumbersome. And you saw that in the video. I had to copy paste a bunch of different contracts from OpenZeppelin, so on and so forth. In this video, it's going to be done in just one line, one command, and it will automatically verify using a plugin to Hardhat that will integrate with the etherscan API. And this will work on Ethereum with etherscan, it will work on Binance Smart Chain with BSCscan, it will work on Polygon with polygonscan. So you can use the same principle, but a little bit of a different configuration. I will leave some links in the description with instructions on how to use it on these other networks. But first of all, let's check out the code that I used to accomplish this, and then I'll walk you through step by step in a while, but I'll show you first how it works. So I do have my contract here, which I've shared on the channel before. This is an NFT contract. It's based on the OpenZeppelin ERC1155 standard, which I import here. I mint an NFT called Sword here in the constructor, and that's about it. This contract is very short, but it does have lots of dependencies through this import statement right here, because this Solidity file is one very big Solidity file. That Solidity file in turn inherits from multiple other Solidity files. So it becomes pretty complex to do it manually, so that's why we're going to do it here automatically. I do have a script which is called deploy, which will deploy my NFT script, which this is just the standard. I didn't even rename this because this comes from the standard sample script that it's provided by Hardhat in the template. But this deploys the NFT script, and then in the Hardhat config, here is the actual interesting part. So first of all, you need to add the testnet that you're going to use, or the network that you're going to use. Maybe you'll use the mainnet. And then you need to add the etherscan API key like this. And I will show you, as I said later on, step by step, exactly how I do this. You get this from the etherscan account that you register, and the network here, you need to add to the secret.json, and then import that up here. And there you should have a URL to a provider. You can use Moralis for that. And then a private key that you need to have some testnet ether on. And the last thing you need to do that actually has to do with this verification is that you need to install this Nomic Labs /Hardhat etherscan. That is a plugin that you need to install using npm, and then you need to require that in this file right here. And once you have all that, the actual verification will work like this. So we can run, first of all, we're going to deploy our deploy script right here. So we're going to run npx hardhat run scripts /deploy.js -- network ropsten. Okay, so this will deploy our contract, and then we're going to use the verify plugin to automatically verify this on etherscan. And now when that's deployed, we can run our verify command. So npx hardhat verify, that is the command. And then we need to specify the contract address. And then we need to specify any constructor arguments. But we don't have any constructor arguments, so we can leave that empty and just press enter. We need to select the network ropsten. Successfully submitted source code. Now it's waiting for the verification result from etherscan. There we go. Successfully verified contract NFT on etherscan. Now we can copy this URL and check it out in our web browser. And now we can see contract here is verified, contract source code verified, and we can read this contract, we can write this contract, and anyone can see our code, and it's verified using the bytecode that is on chain, that this contract that we injected right here actually corresponds 100% to the code that is deployed on this address. And that's what's so powerful about this verification. Now, let me show you what I did in order to get this to work. So I'm gonna do it step by step now. So I'm gonna create a new project. Here I have a completely empty project now, and I'm gonna begin by initializing a new Hardhat project. So I'm gonna npm install Hardhat first of all. And then we're going to run npx hardhat to initiate our project. And here we can select what we want to do. We want to create a basic sample project. Project root is going to be here. We can add a git ignore. And now we have the basic structure for our contract. But this contract we're not going to use. So we're going to remove this file for now. Delete, and we're going to create a new file here called nft.sol. And as you saw, I imported the OpenZeppelin code here, so I'm gonna npm install that. So npm install at OpenZeppelin/contract. That way I get all of the OpenZeppelin contracts, and then I can import those here in this file. So pragma solidity. Where is this? There we go. 0.8.0. And then we're gonna import, let's see, at OpenZeppelin/contract/ what is it, token? It's here. OpenZeppelin, yeah, token /ERC1155/ERC1155.sol, I think. And then this needs to be a string, of course. Yes. Perfect. And then contract NFT is ERC1155. So I'm not gonna walk you through all of the steps of creating this contract, because this is actually not the tutorial about how to create an NFT. I'm gonna call mint message.sender ID 0. We're gonna make 1 and empty data. So this is just a bit quicker than previously. Previously I created a constant variable here, but it's the same contract. Complaining that it's not abstract. I missed something here. Let's see, npx hardhat compile. Let's see what it says. Okay, yeah, let's see. We forgot to install some of the dependencies for the Hardhat. Right, we're gonna npm install at Atomic Labs Hardhat waffle, this one, and then also Atomic Labs /hardhat -ethers ethers and chai. Those are needed to run the compile and the test and deploy commands. So we need those. Now let's try again. npx hardhat compile. Oh yeah, of course. Here is the issue. I need to run the ERC1155 constructor as well, and here it's expecting a URL. I don't need to pass in a valid URL, but I'm just gonna pass in some random string. Let's compile this. There we go. Compile finished successfully. So now we can move on to actually doing the configuration and the verify plugin. Okay. So first of all, we need a way to deploy this. So the sample script, I'm gonna rename it to deploy.js. And we can leave most of the stuff in here, just that we're gonna rename this to NFT instead of greeter. And then we're going to get the contract factory. It's called NFT. It doesn't have any constructor arguments, like so. And that's all we need to do for the deploy.js file. Very easy. Finally, we need to modify our Hardhat config file in order to be able to use the verify plugin. So first, we're going to npm install this plugin at nomic labs slash hardhat dash etherscan. And at the same time, we can write in here the same thing. We're going to require this, the same package here that installed without issue. And then we need also to modify this module.exports down here. We need to add a networks object, and here we're going to put ropsten, and here we need to put some few secret details. First of all, we need to have the URL, which we're gonna get from our secrets dot URL, and then we're gonna get accounts. Here we need to add our private key, and this is gonna be secrets dot key. That, and then we need to create a file, but we also need to require it. Well, let's do that later. We're gonna create the file secrets.json, and this is important that you don't commit to any repository. Here we're gonna add URL, which we're gonna get from Moralis, and here we're gonna add key, and this is gonna be our private key as a string, and this was a string. So URL is easy to get. That is a URL to a Web3 provider. I'm gonna go to admin.moralis.io. Need an account here. Go to speedy nodes, ETH network, and we're going to grab the ropsten URL here. And you need to add that here to your URL. And then the key, this needs to be a private key to a wallet that has ropsten test network ether. So you need to find a faucet, like this one, for example, faucet.ropsten.be. Enter your ropsten testnet account here, and then send me test ether. And then you need to get your private key for that specific wallet and paste that here. So I'm not going to show you mine, but you should paste that in here and then save it. And you can export your private key from your MetaMask wallet, of course. And once you have saved that, you're going to require up here /secrets, or let's see, /secrets.json, and then we can use that here as secrets.url and secrets.key. Maybe we shouldn't actually put .json here, I don't know. Just /secrets should be fine. And now we're also going to add the etherscan part, because you do need to have an API key to etherscan in order to do this. So etherscan is also an object, and here we need API key. And here you need to put your etherscan API key. How do you get an etherscan API key? Well, you simply sign up to etherscan.io for an account, and then you go to API keys. You take an API key here, which you create from here, add, you call it something, you continue, you get an API key here, you paste that into here, and now we should be good to go. We have everything we need. So let's try this out. We already compiled, so let's try to run our deploy script. npx hardhat run script / deploy.js -- network ropsten. Secret is not defined. Of course, we need to do let secrets be equal to require. Now let's see if this will deploy. There we go. It's deployed. And now let's try to add our verify script. npx hardhat verify. We're going to paste the address. Then -- network. Waiting for verification. There we go, successfully verified. And that's it for this this video. Now you know how to verify a contract using Hardhat, and this is going to save you so much time when you're working with a large project, because you cannot copy paste every single contract into etherscan. I mean, you not only have to copy this, you have to copy basically everything that is inherited from this and all of the contracts under that. So this will save you a ton of time. It just takes you a few seconds and just a few minutes to set up. I hope you enjoyed this video. Check out the links in the description if you want to do this on Binance Smart Chain or Polygon, for example. And let me know in the comment section if you have any questions. Thank you for watching.